In this video, we're going to be taking a look at observational studies versus designed experiments. So let's start by, basically, let me back up. In the last video, we were taking a look at the guidelines for planning a statistical study. And there are several different kinds of things that you can do when you're doing a statistical study. Just like there are several different kinds of methods that you can use to generate your sample. So there are, generally speaking, three main kinds of studies. There are observational studies, there are designed experiments, and then there are surveys. Okay, so we're going to take a look at observational studies and designed experiments in this video, and then we'll come back and look at surveys in the next video. Okay, so let's start by discussing the observational study. The defining characteristics of an observational study is that measurements and observations are obtained in a way that theoretically does not change the response or variable being measured. And in these types of studies, the researchers do not exert any kind of control. So, a couple of things I want to mention about this definition. First of all, you'll notice that I've inserted this word theoretically here. Measurements and observations are obtained in a way that theoretically does not change the response or variable being measured. The idea with an observational study is that the researchers are simply supposed to observe and record. There's a variable that you're trying to measure. You observe that variable and you record what you see. You're not assigning people to treatment groups and control groups. You're not asserting any kind of control over the subject in the experiment. You're just observing the subject and recording the variable. And you're supposed to do this in a way that isn't changing the response. Now, in certain circumstances, that's relatively easy to do. If, for example, I wanted to find out how cancer cells responded to a certain medium, I could simply, observe what happens when those cells get exposed to that medium, right? So I could just observe and record. The cancer cells don't care that I'm watching them, right? They don't care that they're being observed, so I'm not changing their response or the variable that's being measured. I'm just putting them in the medium and watching what happens, right? That's it. Now, if the individuals included in your observational study are people, this is a lot harder to do if they know that they're being observed. So, for example, if you go to see a nutritionist and the nutritionist is trying to help you, maybe lose weight, and so they say, okay, the first thing I want you to do is I want you to start keeping a food diary. So I want you to write down, everything that you eat for the next week, and then next time we meet, we'll discuss what you've eaten. Just the fact that you know that somebody is going to be reviewing your choices is likely going to change your behavior. So because of that, if the individuals in the study are people, and if they know they're being observed, it might actually, just the fact that you're observing them, change their response or change the measurements that you would get. So in theory, you're not changing the response, but if the people realize they're being observed, that might be an issue. Okay, so observational studies, we're just observing and recording. Now, because we are just observing and recording, the drawback of observational studies is that they cannot be used to establish cause and effect relationships. between variables. And the reason that they cannot be used to establish these cause and effect relationships is because the researchers didn't have any control, right? If I simply observe people's diets, let's say I'm interested in the effect of diet on heart disease. So I'm going to observe people's diets. I'm not going to have any treatment groups or control groups. I'm just going to observe diets and measure rates of heart disease. Even if at the end of that study I'm able to show that people with healthier diets have less heart disease, I can't say that it's because of the healthier diets, because I didn't control any other sources of variability. It's possible that if heart disease was lower in individuals with healthier diets, that it was because of the diet. Might also have been because of exercise or other genetic factors. I didn't make any attempts to control any of those variables. I just observed and recorded. So observational studies can't be used to establish cause and effect relationships between variables. We can simply see that there might be a relationship, but we can't say that it's causal. Okay. Designed experiments, by contrast, are very different. All right, so in designed experiments, a treatment is applied to the individuals in the experiment in order to observe a potential effect on the variable being measured. And here we tend to think of treatment as a medical term, but it could be that treatment is a diet that you're trying, it could be a tutoring program that you want to observe, it could be a new paint color on a car that you're test marketing. Okay, anything that the researcher is applying to the individuals in order to observe a potential effect, that is a treatment. Okay. Designed experiments are how we establish cause and effect relationships. So they are used to establish cause and effect. And we can do that because the researchers have control over the variables in the experiment. And a lot of times, to measure the effect of a treatment, researchers may break the individuals into the treatment group, treatment, and control group. Now, I'm assuming a lot of you have probably heard this term control group before, but we'll go ahead and talk about it. Treatment group is the group that gets the thing that's being studied. So if it's a new medication, the treatment group gets the medication. If it is a new tutoring program, the treatment group gets the tutoring. If it's a paint color, the treatment group gets the paint color. The control group is simply the group that does not get the treatment. So they don't get the medication, or they don't get the tutoring, or they don't get the paint color. Okay. Now, sometimes, in some circumstances, we'll go over some terminology that's used with designed experiments. In some circumstances, this control group will get what's called a placebo. So these are terms associated with experiments. Placebo is something, like I said, you may have heard. So sometimes the control group gets a placebo. And a placebo is something that is indistinguishable from the treatment, but is not the treatment. In the case of medicine, this is frequently a sugar pill. So if we want to determine the effectiveness of a new medication, I would give the treatment group or treatment groups if there are plural groups. Maybe we have 3 different groups of the medication at 3 different dosages. And then maybe there's a control group that doesn't get the medication, but they would be given a sugar pill that would look just like the medication, but it wouldn't contain the active ingredient. The reason that you sometimes do this is to isolate the placebo effect. Sometimes people's behavior and responses change just because they know they're being given some kind of treatment. And so the sugar pill helps to essentially figure out how much of that improvement is due to the placebo effect versus how much is actually due to the treatment. So if the control group that's taking the sugar pill improves just as much as the treatment group, then we know that it's not really the medication that actually did anything. It was a psychological effect of being told that they were being given something. Now, in some circumstances, a placebo cannot be given. If, for example, we had our tutoring program that we wanted to test, our treatment groups would get the tutoring. Our control group wouldn't get a placebo, they would just get no tutoring, because there's not really a way to give your control group something that looks exactly like tutoring, but is not in fact tutoring. Okay, so it's not the case in all circumstances that you would be able to use a placebo. Other terms that you may have heard associated with experiments would be lurking variables. These are variables that were not part of the data collection, but have an impact on the variables included in the experiment. Okay, so they're lurking variables. We didn't actually collect any data about them, but they're actually impacting the variables that we did include. In the observational study example that I gave you previously, where we were looking at diet and heart disease, if those are the only 2 pieces of data that we collected, exercise or fitness level could be a lurking variable. People who are more fit tend to also be likely to eat healthier, so fitness level might have an effect on diet. Fitness level also likely has an effect on heart disease and heart disease risk. So it wasn't part of our data collection plan, but it has an impact on the variables that we did actually include. Okay, this is one of the reasons that you can't use observational studies to pin down cause and effect relationships, is because of these lurking variables. Whereas experiments, because they have multiple treatment and control groups, experiments tend to make efforts to control for those lurking variables. Other terms associated with design experiments: blocking. And to explain what blocking is, I'm going to give you an analogy. So blocking is to experiments what stratifying is to sampling. Okay, blocking is the same thing as stratifying. It's just that when you're creating a sample, you call it stratifying. When you're doing it in an experiment, you call it blocking. Okay, so here's how a basic designed experiment would work if we were testing a new, let's say, cholesterol medication. I would have my subjects. and they would get randomly assigned to a treatment group and a control group. And let's say that the control group gets a placebo, and then the treatment group gets the active pill. Okay. And then typically at the end, you would just compare the outcomes. Okay, the treatment group, the control group, you would compare. Or if you had multiple treatment groups, so treatment number 1, treatment number 2, if you had different dosages you wanted to test, you could have a bunch of treatment groups, a control group, and at the end you would compare. Okay, now that is an unblocked experiment. That's what's called the completely randomized experiment. You could also employ blocking. And blocking is what you would use if you thought there was some kind of characteristic of the individuals in the study that could have an impact on their response to the treatment. So for example, because male and female physiology is different, a lot of times men and women will have different responses to medications. So rather than doing a completely randomized design, I could do what's called a randomized block design. I'm going to start with my pool of subjects. I will split them, or I will block, rather, by gender. So I have the males and the females. See how that's essentially like stratifying? We're taking our entire pool of subject and we're splitting them out according to a demographic characteristic. Then within each block, I would do treatment and control, and treatment and control, and then at the end, compare. So now I can not only see was there a difference between the treatment and the control group, but I can also see was there a gender-based difference in response to the treatment. And you can block by any number of characteristics. Here, males and females just happens to be a category of 2, but you could block, if you were doing a designed experiment, by socioeconomic status that could have 3 or 4 different levels. You could block by age group. You could have 5 or 6 different ways you wanted to split it out. Okay, but that's the idea with blocking. And then the last piece of terminology that you'll see that's commonly associated with designed experiments is the notion of blinding. And this is one of the ways in designed experiments that we attempt to avoid bias. Okay, so in blinding, there are 2 kinds of blindings. There's single blind and double blind. Single is when only the subjects don't know what group they have been assigned to. Okay, only the subjects don't know what group they've been assigned to. That's single blinding. With double blinding, neither the subject nor the people collecting the data know who has been assigned to which group. And this is important to avoid bias, right? Double blinding in particular, because as a researcher, if I'm doing some kind of research where I'm going to be interviewing the subjects to find out about their responses, it is possible that if I know what kind of treatment that person has been getting, whether they're in the treatment group or the control group, I might inadvertently influence them to have certain kinds of responses. So if I don't know and they don't know what group they've been assigned to, that's going to actually give me more robust statistical conclusions. Similarly, with the single blinding, it's more robust than no blinding at all. But sometimes this isn't even possible. Again, if you're talking about evaluating the efficacy of a new tutoring program, obviously you know whether you're in the group that's getting the tutoring program or you're not. So Sometimes single and double blinding are possible. Sometimes only one or the other is possible, and sometimes neither of them is possible. But that's the idea with blinding. In the next video, we're going to be taking a look at surveys.